So now we are going to discuss some problems on fuels and combustion chapter. So first we have seen the problem number 1, which is shown as propane gas is reacted with air in such a ratio that an analysis of the dry products of combustion gives CO2 is 11.5%, O2 as 2.7%, and CO as 0.7%. Now the question is, what is the percentage of excess air used? So first we have to write the complete combustion equations as I mentioned earlier. Here you can see propane is indicated by C3H8 and A is the number of moles of oxygen used. So AO2 plus 3.76 into A into N2 equal to the products of combustion. As there will be CO2, there will be CO, there will be O2 as in the question. Along with this there should be N2 because it carries the nitrogen in the product of combustion equation. So there will be N2 and there will be also H2O. So equating the coefficient, we can be able to find out the amount of carbon as indicated over here in the left hand side C3. So there will be 3 units of carbon, and if we follow the right hand side, the carbon is along with the coefficient B and D. So we can write as 3 is equal to B plus D. Similarly, if we go on, then the next is H. So if we want to make a balance over H, then you can see it has 8 units on the left hand side and the right hand side is indicated by G. So GH2, so there will be 2G. So 8 equal to 2G. From there you can find out G, and we can make the similar thing for ON also. And if we follow the DFG analysis, that is dry flue gas analysis, in that part you have to neglect this H2O because dry flue gas analysis consider only the dry products. So by this, as it indicating as the CO2 in question number 1, you can see the CO2 is 11.5%. So you can write CO2 is indicating by coefficient B. So you can write B divided by B plus D plus E plus F. Here we are not going to consider G because it is dry flue gas analysis. So there will be no liquid particle considered in that DFG analysis. After that, the D by this, that means the percentage of D indicated by CO. So CO is 0.7%. So D by this is this and E by this is this. And so from here we can find out B by D by doing this, dividing by equation 1 with 2. Suppose B by D is this, B by E is this, D by E is this. So B plus D we have already find out equal to 3 in C balance, and B by D is cover 16.43. From there you can find out B, we can find out D, and similarly E and all the values, and A also. After that we used to find out the actual air supply, as it will be 5.578 into 32, as 5.578 is A and 32 is a molar mass of oxygen because O is equal to 16. So O2 means 32 and N is 14, so N2 means 28, and 32 plus 3 into 3.76, sorry 3.76 into 5.57 into 28. This is from the nitrogen part. So the total actual air supplied is 765.748 kg of air per kg mole fuel. So the corresponding stoichiometric equation is C3H8, which describes the balance in mass in proper form. That's why here we got A is equal to 5.578. Rather, in the stoichiometric equation we used 5, so that we can make a proper balance. So C3H8 plus 5O2 plus 5 into 3.76 N2 is equal to 3 CO2. If we want to make the balance of carbon, there are 3 units, there are also 3 units in the right hand side. If we go on with the H, there are 8 units of H, and here you can see 4 H2O. That means there are again 8 units of H. If you go to the oxygen, there is 10 in the left hand side, and the right hand side you can see 3 O2 CO2, so there will be 6, and there will be 4 H2O, there will be 4, so 6 plus 4, that is 10. It's perfectly balanced, and from there you can find out the theoretical air supply as 5 into 32 for O2 and 18.8 come as 5 into 3.76, 18.8 into 28. So it comes 686.4, and from there you can find out the percentage of excess air, as it will be WA minus WT divided by WT. This WT is sometimes also known as stoichiometric air supply. and from there the percentage come as 11.56. That is the answer for our question, as we have to find out the percentage of excess air. Okay, now I move to question number 2. Just follow the question number 2 in the upper side. In an oil-fired boiler, the fuel had an analysis by mass of this, and just so follow the question first. It given as carbon is 84%, hydrogen 10%, sulfur 3.2%, oxygen 1.6%, and the remainder is incombustible. And the analysis of DFG is given as combinedly CO2 plus SO2 is 15.72, O2 is 1%, and there being no CO and there is no SO3. Calculate per kg of fuel, mass of air supplied, percentage of excess air supplied, mass of dry flue gas form, mass of water vapor form. So let's move to question number 2. Here you can see, first we are considering equation, complete combustion equation based on 100 kg of fuel, and X moles of oxygen are supplied for combustion. So you can write 84 by 12. Why it's 84? Because 84% carbon is there and the molar mass of carbon is 12. That is why 84 by 12. Similarly for H, it's 10% of hydrogen. So 10 by 2, because hydrogen is equal to having molar mass 1. You can write the equation and here you can see neglecting those terms as it asked in the question. So we are going to write the complete combustion equation, obviously based on following given conditions. So again, equating the coefficient, we can find out 84 by 12, that is the carbon in the left hand side, and in the right hand side the carbon is indicated by a coefficient B CO2. So it will be 84 by 12 is B, so B is equal to 7. So we can find out the corresponding value of G and etc. And from the volumetric analysis or the DFG analysis, where the dry products are only considered the right hand side mainly. So B plus D, because a combination effect of CO2 and SO2 is given as 15.72%. So we can write B plus D divided by B plus D plus E plus F. Here you can see considered B, D, E, F, but G is neglected because in volumetric analysis or DFG analysis, we are never considering the water part. That's why G is being neglected. So by putting all these values, we can find out the value of X. So mass of oxygen as it comes is 10.002 into 32, because the molar mass of oxygen is 16, so O2 is 32, 320.1 kg. And from there, mass of air supply we can find out for 100 kg of fuel, it's 321 by 0.232. Why? Because the air contains 23.2% by mass, 23.2% of oxygen by mass, and the remaining percentage is nitrogen if we neglect the other constituents. So mass of air is 1380 kg, that is the amount of air supplied to 100 kg of fuel. So what about 1 kg? It will be 13.80 kg. Now trying to find out the theoretical air supply or the stoichiometric air supply. That is the minimum quantity of air that is required to make the combustion process. And you can find out by this equation as WTH is 11.5 C, as we can see, plus 34.5 into H by O by 8 plus 4.3 S. Here you can see carbon percent is 84, so C will be 11.5 into C will be 0.84. 34.5 into H, the hydrogen percent is given, the oxygen percent is given, sulfur percent is given. So put all these values over here, and from there you can find out a WTH, as WTH is come as 13.18 kg. So from there you can find the percentage of excess air as WA minus WTH by WTH, it comes as 4.7%. And the mass of dry flue gas form for 100 kg of fuel, we can find out as from the right hand side B CO2 plus D SO2 plus EO2 plus FN2. Here again we used to neglect the H2O part. And CO2 is 44 as C is 12 and O is 16. So 16 into 32 plus C, that is 12, so 44. D into SO2, so D is 0.1 as it comes, and SO2 is 64 because S is sulfur is 32, the molar mass, and O2 means 32. So E into O2, O is 16, so F into N2, this is 28, and F is come as 3.76 into 10.002. So finally, mass of flue gas formed for 100 kg come as 1381.87 kg. So for per kg of fuel, it will be 13.82 kg. And mass of water vapor formed, it will be GH2. G is come as 5 and H2O is equal to 18 because H2 means 2, H is 1 and O is 16. So 2 plus 16, 18. So 5 into 18 divided by 100 because we used to find it per kg of fuel. So it comes as 0.90 kg. So by that way, I am just giving an intro regarding the question number 3. So try to formulate the equation as it's shown here. Then go with the procedure as I mentioned earlier. Clear? So try to solve some problems, more problems on fuels and combustion chapter in that way. So that's all from today. Okay, thank you.